Okay, the date is... It's Friday the 5th of September 2014, as you could probably see from the date this video was published. And I would like to take this opportunity to speak about my theory of space density and space mass, which, as far as I'm aware of, is my own theory that I came up with. Who knows, maybe someone else came up with it as well, but if they did, I never read about it. So here it is anyway. Basically, the idea is where to begin. Okay. Is in astrophysics, they talk about space bending, and they talk about a large mass like a star will cause space to bend towards it, which has been proven by light being seen to bend. But the strange thing about it is that space itself obviously has no mass, and gravity is supposed to only affect things that have a mass. I think there's a lot of contradictions in that theory that don't really make sense. Firstly, first that one that I just mentioned. Secondly, there's originally they noticed that light was getting bent when it went around a star. So obviously, as light is not supposed to have a mass, they couldn't understand why. So then they decided to do it because it was space was bending. But that brings out a whole other can of worms. And when you talk about space bending, what is it bending into? As far as I'm aware, no one's really figured that one out. But anyway, here I am to explain the mess. It also explains lots of other problems like time dilation and relativity problems. It'll get explained by my theory. So, first of all, let's understand that physical matter, is basically energy, little bundles of energy. And I mean, it helps to think about it in terms of the old kind of classical idea of atoms and molecules being like little balls. They probably aren't, but it doesn't really matter. At the end of the day, we're still just talking about little regions of space, however tiny you want them to be, or even if you want them to be strings or whatever. But let's just say it's a little ball. So inside that little ball, of that atom, is some space. Or essentially the energy, the bundle of energy that is physical matter is space. Space is energy, energy is space. Or the energy occupies a region of space, right? So you could just as easily say that a whole bunch of atoms is a whole bunch of space as well. So what I'm saying is that when you have a dense region of atoms, if you have a lot of atoms compressed together, you're also compressing a lot of space together, because the space is kind of, how shall I say it? If you imagine space as being like elastic, it stretches, but there's never any break in it. So you can get dense regions of space where there's lots and lots of atoms, and you have a high density of matter. You also have a high density of space, hence space density. Okay, and it occurred to me that this could be the explanation for gravitational lensing and light bending, because obviously a lens made of glass the light bends because of the different thicknesses of the glass, which cause the light to bend. So in the same way, when you have a big massive bundle of atoms like a star compressed together, you're also compressing massive amounts of space together. So all the space which is connected to those regions of space that are occupied by the physical matter is pulled towards it, like stretched towards it. So that's how you get the sort of stretching effect. But it's not actually space bending, it's just density of space. So you've got a very dense region of space, which is the star. Around the star, you have a smoothly deteriorating density of space that as it sort of tails off away from the star, eventually it goes back to the kind of average kind of natural density of space that exists everywhere in the universe. And so obviously as light travels through a denser region of space, it will be bent, it'll be refracted like a lens. So this does away completely with the idea of space bending, because obviously, well, to me anyway, the idea of space bending doesn't really make sense. I don't think it really makes sense to anyone. So you don't need space bending anymore. So it's much simpler. And it also explains a lot of things like time dilation and in relativity theory, because there's another classic experiment where, or a sort of theoretical mind experiment which explains time dilation, which says that, if you had a spaceship with a laser on it, and you fired the laser across a room, the laser would take, let's say, just for hypothetical sake, it takes 1 second. Obviously, it wouldn't take a second, but let's just say it takes 1 second to cross this very long room in the spaceship. And then you imagine the spaceship is traveling very fast, and the idea is that the laser, because the spaceship is moving as well, the laser light has actually covered a longer distance to an observer outside. So they say that how can the laser have travelled the same distance whereas it seemed to have taken the same amount of time? So they say, well, the speed of light is constant, so it can't have travelled quicker, so therefore the time must have slowed down inside the spaceship. Okay, I would say that's ludicrous. And I would also say that if there was a human being on the spaceship, they would not experience time slowing down, because consciousness itself, you see, this is something they never dare to talk about. If time slows down, would your consciousness slow down as well? I don't think so somehow. I think consciousness is a constant. And I think if you're talking about time slowing down in the fast-moving spaceship, you would definitely notice that, because your consciousness wouldn't slow down as well. And that needs to be spoken about. Physicists need to think about stuff like that, because if we're ever going to travel through space, that's something that is actually going to happen. And they can't just carry on this thing of never talking about consciousness. They're physicists. Consciousness is part of the physical universe. They need to talk about consciousness. Okay, anyway, so I propose that in fact, because there's an actual space is kind of attached to the room, like for instance, there's oxygen inside the room. So there's a field of space, which is actually the actual space moves inside the spaceship. So I like to think of this as, imagine if you got a box, a metal box with, let's say it's got a lid on it, and you put it under the water in a swimming pool. You fill it up with water, you close the lid. If you move that box around, there's an actual piece of water inside the box which is moving around. It's not flowing through the box, it's sealed in there, because obviously the spaceship will be sealed. So the light that's in the moving spaceship has travelled across the exact same distance of space. It doesn't matter if you're standing outside the spaceship looking at it, because the space has actually moved with the spaceship, and therefore the light has travelled the same distance. Therefore there's no need for relativistic time dilation. Okay, so we can get rid of that weird little problem as well, because it doesn't really make sense. There's another theory where they say about two people, if you're if there was two people floating in space, imagine there was two people just floating in space, nothing around. One of them was to move away from the other one really fast. Which one would experience the time dilation, because they're essentially both moving away from each other. And there's this whole thing where it gets all confusing, where they talk about which one is moving away from the other one, and it doesn't really make sense. I'll have to make another video about that when I could research it, but I think any physicist listening to this will know what I'm talking about. They start to come to all sorts of strange conclusions about how do you determine which is the object which is moving and which is the one at rest, and it kind of doesn't really make sense. I think it's much more logical to think about this space density theory. I think I've pretty much covered it there. Anyway, you heard it here first. Conscious Truth, conscioustruth.com, on the 5th of September 2014. And if any physicists come out and say they discovered this theory after this, we'll know that they heard it here first. Well, there you go. There is actually some more to this theory, but it's getting very late. I'll have to make a part 2. Okay. Good night.